If we're looking for a particular solution to a non-homogeneous differential equation where the right-hand side is a trigonometric function, then we guess for our particular solution that it's equal to a constant times cosine plus a constant times sine. So if we have the non-homogeneous differential equation, nth derivative of y plus something n minus first derivative of y plus something y equals f of x. This is non-homogeneous because the right-hand side is not 0. And f of x has the form some multiple of cosine bx plus some multiple of sine bx and plus and minus bi are not roots of the auxiliary equation. Then we let our particular solution be some multiple of cosine bx plus some multiple of sine bx. We plug yp in its derivatives. Into the non-homogeneous differential equation to solve for the undetermined coefficients a and b. Two special cases are, so if c naught equals 0, so that means f of x is just going to be some multiple of sine bx, or if c1 equals 0, so f of x is just going to be some multiple of cosine bx, we do exactly the same thing. So even if we only have one trig function on the right hand side, our guess for the particular solution is still going to be multiple of cosine plus multiple of sine. We'll have both of them here, even if only one of them appears on the right hand side. So for example, let's say we have, let's solve the non-homogeneous differential equation y double prime minus 3y prime minus 4y prime equals 2 sine of x. So our homogeneous equation is y double prime minus 3y prime minus 4, I'm sorry, this should be a regular y here. Second derivative, first derivative, and regular y. And our auxiliary equation is r squared minus 3r minus 4 equals 0. So that's r minus 4, r plus 1 equals 0. So our solution space basis is e to the fourth and e to the 4x and e to the negative x. Alright, we don't have any imaginary roots of the characteristic of the auxiliary equation, so we don't have to worry about plus or minus bi being roots of it. So we're going to guess that we have a particular solution of the form something cosine x plus something sine x. The coefficient of x there is 1, so we don't need to put any additional coefficient inside. Alright, want to plug yp and its derivatives into the left-hand side here, set that equal to 2 sine of x, and then use that information to solve for a and b. So our first derivative, yp prime, is going to be negative a sine x plus b cosine x. And second derivative is negative a cosine x, derivative of cosine is minus sine, minus b sine x. So y double prime minus 3y prime minus 4y got the second derivative, minus a cosine x minus b sine x minus 3y prime. So plus 3a sine x minus 3b cosine x, and then minus 4y minus 4a cosine x minus 4b sine x. And this should all be equal to, when we add it up, 2 sine x. So 0 cosine x plus 2 sine x. So that is, let's see, we have negative 5a minus 3b equal to 0, and 3a minus 5b equal to 2. So let's add 2 times equation 2 to equation 1, so that we add 6a here, and then we'll just get 1a. So equation 1 becomes equation 1 plus 2 times equation 2. And we get negative 5a plus 6a is a, negative 3b minus 10b is minus 13b equals 0, plus 2 times 2 is 4. And then 3a minus 5b equals 2. Then we can let the second equation be second equation minus 3 times the first equation. And then we get, let's say 3a minus 3 times a is 0. Negative 5b plus 39b is 34b equals 2 minus 3 fours. 2 minus 12 is negative 10. So I guess we can see right now that b equals negative 10 34ths, which simplifies slightly to negative 5 17ths if we divide top and bottom by 2. So a is going to be 4 plus 13b. So let's see, 4 times 17 is 2 times 17 is 34. So 4 times 17 is 68. So 68 over 17 plus 13b minus 5 times 13 over 17. 5 times 12 is 60. So 5 times 13 is 65. 68 minus 65 over 13 is 3 over 17. So the particular solution we want is 3/17 cosine minus 5/17 sine. (3/17 cosine x minus 5/17 sine x. Instead of all solutions to NH, this equation is that particular solution, 3/17 cosine x minus 5/17 sine x plus anything in the homogeneous solution space, or everything in the homogeneous solution space. So plus multiple of e to the 4x plus multiple of e to the negative x. All of this where C1 and C2 are real numbers. Alright, now a complication arises if we have bi and negative bi being roots of the auxiliary equation. Then we multiply our guess yp if the roots of the auxiliary equation of multiplicity m. Then we multiply our guess for yp by x to the m before differentiating. So let's do an example of that. Let's solve the non-homogeneous equation y double prime plus 4y equals sine of 2x. So the homogeneous equation is y double prime plus 4y equals 0. The auxiliary equation is r squared plus 4 equals 0. So that's r plus 2i, r minus 2i. Going off the board. That means plus and minus 2i are roots. The basis of the solution space is we have no real part there, so we don't need an e to the x, e to the ax, but we have cosine 2x and sine 2x. So all possible linear combinations of cosine 2x and sine 2x are solutions of the homogeneous differential equation. Now normally we would guess yp equals some multiple of cosine of 2x plus some multiple of sine of 2x because of the right hand side, sine of 2x. But cosine of 2x and sine 2x are already solutions of the homogeneous system. So we know if we plug them into the left hand side of NH, we're going to get 0, not sine of 2x. Now since 2i and negative 2i came up as roots of the auxiliary equation with multiplicity 1, we multiply this by x to the first and then take derivatives. So since plus and minus 2i are roots of the auxiliary equation of multiplicity 1, we multiply our guess, I should say we multiply the normal guess by x to get yp equals ax cosine 2x plus bx sine 2x. Alright, we need this and the second derivative to plug into the non-homogeneous differential equation. So I guess we'll differentiate once to get, we've got product rule. Derivative of the first times the second plus derivative of the second. So that's sine of 2x times 2, but minus sine of 2x times the first. Ax. Alright, and then product rule on this. Derivative of the first, b times the second, sine of 2x, plus derivative of the second, plus 2 cosine 2x times the first, bx. And then the second derivative is, derivative of cosine is negative sine, negative 2a sine of 2x minus 4 cosine, oh, I need to use product rule. Maybe I'll do this because there's no product rule there. So plus 2b cosine 2x. Alright, and now to do product rule on these. This is, I'm going to rewrite this as minus 2ax sine of 2x. Minus 2ax sine of 2x. And I'll rewrite this as 2bx cosine of 2x. Alright, here we go. Derivative of the first, minus 2a, times the second, sine of 2x, plus derivative of the second, cosine of 2x times 2, times the first, minus 2ax. And this could be written more neatly as minus 4ax cosine of 2x. Alright, then we need derivative of this. Derivative of the first, 2b, times the second, cosine 2x, plus derivative of the second, which is minus 2 sine 2x, times the first, times 2bx. And that could be written more neatly as minus 4bx sine 2x.